moving. In proofs, you always have to have a reason for what you're doing, explaining what you're doing. And a lot of our reasons come from the postulates that you guys already know. Remember, a postulate is just an accepted rule or statement that you have to follow. You don't really have to explain why. When there's 2 points, you can have a line through it. Euclid just said that's what it is. Some of our postulates are just that, just sentences. Through any 2 points, there's 1 line. If 2 lines intersect, then their intersection is a point. We have 2 named postulates. They actually have a name to them. The segment addition postulate and your angle addition postulate. And all these are typed down on the top of 2.4. So some postulates get named, some of them don't. You just have to know these. Most of them we've already been using, but they're going to become reasons in your proofs. Before we get to the proofs, we're going to practice looking at diagrams and understanding diagrams and learning what we can get from them and how they're marked. So at the bottom of the first side there, it says, state the postulate illustrated by the diagram. So the first one, if something, then something. And I don't know if you can tell on your picture or not, but the conclusion diagram has a highlighted dot here. This diagram is illustrating one of the postulates from above. Anyone have any idea what postulate it is, Micah? Good. If 2 lines intersect, then their intersection is a point. That's what you have to put underneath of it, write out the postulate. Okay, how about the second one? What postulate do we have there? Spence? Good. If 2 planes intersect, then their intersection is a line. So being able to identify and understand that from hypothesis to conclusion in these diagrams, something is changing, something is being highlighted. We're going to practice reading diagrams again, so go ahead and flip it over. Example 2 says, which of the following statements cannot be assumed from the diagram? So we have 5 statements here, and we're going to figure out which ones we can see or we can conclude from the diagrams and which ones we wouldn't be able to. Take a look at your diagram. You have 2 planes, S and T. T is blue up on my board, and it's vertical. S is horizontal and red. How do I know that these are the names of the planes and they're not called E and F? Why can't I call the red one plane E? Spencer? Right, because they don't have a point next to them like E did, and it's not sitting on a line, so I just know that's the name of the plane. Good. You have a couple lines on the picture, and I don't know if you can see it very well on yours, but there's also this symbol next to point B. What does that symbol represent or tell us? Yeah, it's a right angle. Good. There's a right angle right there. All right. So looking at your first statement, can we assume or can we tell that A, B, and F are collinear points? Yeah, aren't they all written on one line? A, B, F. So since we can assume it, let's just cross it off because we're looking for the ones that we can't assume. So we'll just cross that out. How about E, B, and C? Can we tell if those points are collinear? Why not? Yeah, B and C are already on their own line and E isn't. And I can't bend this line to touch E because then it becomes a curve and it's no longer a line. So this is something that we can't assume. Third statement, segment AB is upside down T to plane S. Can you assume that segment AB is upside down T to plane S? What does upside down T mean? Oh, okay. How do you know that segment AB is perpendicular to plane S? Awesome. Segment AB starts at A, ends at B, endpoints. And plane S, the red one, form a right angle. So yeah, we can assume this. How about segment CD being perpendicular to plane T? Why not, Spencer? And there's also no, there's no right angle mark saying that they're forming right angles, so I can't assume that. It's kind of like that first quiz you took and said, is this a right angle? We should have said no because it wasn't marked. And your last statement, line AF intersects line BC at point B. Can we assume that? Sure. AF intersects BC at B. So yes, we'll cross that off. Not so much today, but towards the end of the week when we get into more of the geometric proofs, you're going to have more diagrams and you're going to have to be able to understand what the symbols mean, what you can assume and what can't you assume based off of what's given to you. So that's why we're practicing that there. Go ahead and flip it back over to the front side to those two boxes that have all the properties in them. Not only are postulates reasons and proofs, bless you, but these algebraic properties will be reasons and proofs, especially for today, because that's all we're doing are algebraic ones. These first four, you've used them for the last year and a half and probably didn't realize that they were actually called a property. The addition property states, if A equals B, then A plus C equals B plus C. Addition property tells you that if you add the same value to both sides of the equal sign, it's still a true statement. The right side is now balanced to the left side. So like in our example here, x minus 3 equals 12. If we were going to solve that for x, you would add 3 to both sides. And last year in algebra, they taught you that if you do it to one side, you have to do it to the other one so that they stay balanced. Addition property, adding it to both sides. The subtraction property, if A equals B, then A minus C equals B minus C. Same idea. If you subtract something from both sides of the equal sign, the same something, then it's going to keep it true. So your example, x plus 12 equals 24. If I were to solve that for x, you would subtract 12 from both sides. It's keeping it balanced. You do it to one side, then you have to do it to the other side. Multiplication property. If A is equal to B, then A times C equals B times C. You can multiply both sides by the same value, and it's still a true equation. It's still telling the truth. 1/2 x equals 14. If I want to get rid of the 2, which is in the denominator, it's doing the dividing, so the inverse of division is what? Multiplication. So you're going to multiply both sides by 2. And the multiplication property says you can do that. And then this last one here, division property. If A equals B and C does not equal 0, then A divided by C equals B divided by C. You can divide both sides of an equation by the same value and it's still true. Your example, 12x equals 36. If you wanted to get rid of the 12, you would have to divide, do the inverse function. How come I have a restriction on C here? Why does it tell me C can't equal 0? What? Yeah, so why can't C be 0 if I'm dividing? Right? Good, because you can't divide by 0. If you put that in the calculator, 12 divided by 0, it's going to say syntax error or domain error. Can't divide by 0. That's all that's telling you. So on your homework today and through our notes, we're going to solve algebra problems, algebraic equations. And then on the right side, we're going to put, I use the addition property. I use the subtraction property. I use the division property. You're going to have to actually not only show your work, but tell me what work you're doing. We have more properties hanging on here. These next three, kind of new. The reflexive property of equality says that A is equal to A, or 7 equals 7. Or 17y is equal to 17y. Reflexive property. Think of the equal sign as a mirror. When you look into a mirror, what do you see? Your reflection, thanks. When you look into a mirror, you see your reflection. It's the reflexive property, okay? Symmetric property. If A equals B, then B equals A. Go back to grade school. Think about when you made hearts in art class. You take a piece of paper and fold it in half, and you just cut out half of the heart, because when you unfold it, you get a full heart, and that fold would be considered the line of what? Symmetry. Good. Just like the capital letter H has a line of symmetry. Well, it has multiple ones. The symmetric property works kind of the same way. The word then is going to be the line of symmetry. If I were to fold this sentence up, my B's would line up, my equal signs would line up, and the A would line up. So in this example, if I'm supposed to use the symmetric property, if 2x plus 4 equals 8, then here's my line of symmetry. 8 equals 4 plus 2x. If I fold it on the word then, the 8's are going to line up the equal signs, the 4's, the plus signs, and the 2x's. Okay, line of symmetry. It really is just flipping your equation around, moving the stuff on the left side to the right side and the right side to the left side. Okay. And then the other one, the last one that's newer, the transitive property. If A equals B and B equals C, then A equals C. The transitive property will have the word and in it. So if you see the word and, it may be the transitive property, but not always. And the transitive property always eliminates the middleman, whatever's connecting them. So if A is equal to B and C is equal to B, well, I can just get rid of the middle guy and just say that A is equal to C. In real life, let's say Michael has a crush on a girl. This girl takes a drink out of her water bottle. Micah goes and takes a drink out of the water bottle, and he can go claim to his lunch table that he just made out with the girl. What? Only if he gets mono. The water bottle is the middle man. Both of their lips touch the water bottle. Eliminate the water bottle, and you get to touch her lips. Yes? That's your transitive property. It gets rid of the middleman. Okay? So in your example, if 2x plus 5 equals 12, and 12 equals x plus 10, well, 2x plus 5 is equal to 12. But x plus 10 is equal to 12. So since they're both equal to 12, we can just get rid of it and set them equal to each other. 2x plus 5 equals x plus 10. Transitive property. We'll have the word and in it, and it eliminates the middleman, the thing they have in common. Okay. You have these three properties, reflexive, symmetric, and transitive, when you talk about geometry also, things being congruent. And this is what's in that second square, or second box. You can have the reflexive property of congruency. Angle A is congruent to angle A. Yep, angle A has to be congruent to itself because it's the same thing. The symmetric property. If segment AB is congruent to segment CD, well, then we can just write segment CD is congruent to segment AB. All it's doing is flipping it around the congruency symbol, or the word then is your line of symmetry. And then the transitive property in congruency, if angle A is congruent to angle B, and angle C is congruent to angle B, there's that word and. They share angle B, that's their common man. So we can eliminate them and just say that angle A is congruent to angle C. Okay. So those three are both reflexive and equality. I missed 2 in the equality. I'm going to go back to them. But it's something you've been doing since last year also. Substitution property. If A equals B, then B can replace A in any expression. You do this all the time. When I say find X and then find me the measures of the angles. You'll solve for X, let's say it equals 6, and then you substitute it back into the expression to find the angle measure. So today, when you substitute it back in, you're going to have to write down substitution. That's what you did. And then your distributive property, hopefully we all know this. A times the quantity B plus C can be rewritten as AB plus AC. Distribute your A into the parentheses. Okay? All right, so when you're doing your homework today and tomorrow and the next day and the next day, because you have 4 days on it, have that sheet open, because you're going to have to identify the properties, show how to use them, and actually tell me when you're using them. Go ahead and flip it now back to where we left off. And you should see justify each step used to solve. And yours should have the 4 horizontal lines. Number 1, that's where we're going. Okay. We're starting to get into proofs. I'm going to go back 1 page. There's 2 different ways, well, more than 2 ways to write proofs. There's like flow chart proofs. There's paragraph proofs where you write them out in papers and sentences. And then there's 2-column proofs. You're only going to be doing 2-column proofs. The left column has your statements or your work. Today it's going to be work because it's all algebra. The right column will give me your reasons. What postulate are you using? Today, what properties is it? Is it the addition property? Is that how you got to this step? Was it this distributive property? Later on, next chapter, you'll be putting theorems and definitions over here, but not quite yet. Okay? So, that first example, justify each step used to solve this equation. They already did all the work for us. We have to go through and figure out what they did. The first step in a proof, whether it's algebraic, one like this, or it's geometric, is always given. So your first blank should be given. Where does this information come from? It's given to you. You're not starting from anywhere or from nowhere. They're going to give you something to go off of. Okay. Your second blank now is how we get from step 1 to step 2. So step 1, 5x minus 12 equals 32 plus x, to step 2. 5x equals 44 plus x. What did they do to get from 1 to 2? Good, they added 12 to both sides. When you add the same value to both sides, what property is that? The addition property. You don't have to put the plus 12s, I'm just doing it to show that. From 2 to 3, 5x equals 44 plus x becomes 4x equals 44. How did they go from 2 to 3? They subtracted x. So if you subtract the same value on both sides, it's called what? The subtraction property. Good. And then from 3 to 4, 4x equals 44 to x equals 11. How did they go from 3 to 4? You divided both sides. And when you divide both sides by the same value, that is your division property. Justifying your reasons to your steps. Explaining why. All right. Next one. Given negative x minus 2 times the quantity 9 minus 8x equals 12, we're proving x equals 2. They're giving you the answer, x equals 2, but I want you to prove, show me the steps, explain why or how you get to that. That's how any proof works. Next chapter, when we get to the geometric ones, they're going to give you something. They're going to tell you what you're trying to prove, your final answer. You just have to figure out how to get there. Okay? Your first step in a proof is always what's given. So you're going to write 1, number your steps, and just copy down the equation. Negative x minus 2 times the quantity 9 minus 8x equals 12. Reason? Given to me. Soon it will say something like angle A is congruent to angle B. The measure of angle C is 30 degrees. So you'd have to copy all that down in your given. We're going to work through this equation to get to what I'm trying to prove. I don't know how many steps they're going to be. Sometimes proofs are 3 steps. Sometimes they're 8 steps. It just depends on how you get there. Okay? You have to show your work and explain why. So if we're going to solve this equation, what do you guys want to do first? Distribute the negative 2 through. So when you distribute the negative 2, your next line should say negative x minus 18 plus 16x equals 12. How did we get there? We distributed. Now what do we want to do to solve for x? Combine like terms, because I have two x's on the same side. So negative x plus 16x, 15x minus 18 equals 12. When you combine on the same side, combine like terms, you can write out combine like terms if you want to. Otherwise, it's called simplifying. When you only do it to one side of the equal sign, it's simplifying it. Now what do we have to do to solve for x? Yep, add 18 to the other side. So step 4, 15x equals 30. And we got here by using the addition property. And then what's my last step I have to do? Divide by 15. What's 30 divided by 15? 2. We got to where we wanted to go. Proofs. Left side tells you your work, what you did. Right side says why you can do it, how you did it. All right. The last example is what's the rest of this page. Half your homework is going to be algebraic proofs, like 1 and 2. The rest of it's going to be naming a property or showing me how you use it. So this first one, if x equals y and y plus 4 equals 3x, then x plus 4 equals 3x. We have to name the property that's being illustrated. And when you're doing this, you guys, you have to read from the hypothesis to the conclusion. How did they get from the hypothesis, x equals y and y plus 4 equals 3x? They get here to here. What did they do? Well, the conclusion, x plus 4 equals 3x, looks really similar to that part in the hypothesis, y plus 4 equals 3x. What's the difference? The x and the y. How are they able to switch them? Because they're the same. So what did they do? They substituted. X is equal to y. So they substituted x in for y and got x plus 4 equals 3x. This would be substitution. B. If x plus 4 equals 3x, then 4 equals 2x. From the hypothesis to the conclusion, what did they do? Simplified? Subtract. Good. They subtracted this x value over. They did it to both sides, so then it would be subtraction. C. If angle P is congruent to angle Q is congruent to angle R, and angle R is congruent to angle S, then angle P is congruent to angle S. Angle P is congruent to angle Q, but Q is congruent to R, so I could just get rid of Q. But Q and R were congruent, and R is congruent to S, so if R is congruent to S, I can just get rid of R, and then that would give me P is congruent to S. What property is that? Spence? This is your transitive property. Think about it like you're getting sick. Paul has a cold and gives it to Quinn. And Quinn has a cold and gives it to Robin. And Robin has a cold and gives it to Sean. Paul gave Sean the cold because it passed through all of them. Transitive, it's getting transmitted through all of them. Yeah? Okay. D. Segment XY is congruent to segment XY. What property is that? It's like that congruent symbol is a mirror. That's your reflexive property. The reflexive property doesn't have if or then in it. E. measure of angle A equals 45, and 45 equals the measure of angle B, then the measure of angle A equals the measure of angle B. What do you think? What could it be? Transitive. A is equal to 45, and 45 is equal to B. We could just get rid of the 45s and say it's transitive. It could also be substitution, because if A equals 45, I could substitute A in for 45 over here. Anytime you use transitive property, you can always use substitution also. Transitive is just substituting more than once. How about F? AB equals AB. That's your reflexive property. This would be the reflexive property of equality, because there's an equal sign, where D was of congruence. G. If the measure of angle ABC plus 40 equals 85, then the measure of angle ABC equals 45. From the hypothesis to the conclusion. How did they get there? Spencer? Yeah, they subtracted 40 from both sides. If you subtract 40 to both sides, then you would get the measure of angle ABC to be 45. Subtract. Two left. H. If K equals M and K plus W equals 12, then M plus W equals 12. They go from the hypothesis to the conclusion. Substitution, good. K is equal to M, so I can substitute M in for K. I. If B is in the interior of angle AOC, then the measure of angle AOB plus the measure of angle BOC equals the measure of angle AOC. What would be our reasoning behind this? Not necessarily a property, but a reason that this would be true. That if I have angle AOC and B is in the interior of it, what tells us that the measure of angle AOB plus the measure of angle BOC would give me the measure of angle AOC? Not congruent. It's not necessarily a property. Yeah, it's the angle addition postulate. The angle addition postulate states if you have a point in the interior of an angle, then the sum of the two angles will equal the third one. Good. Okay, so that is what we are doing today for notes. We're going to stop there.